The annelids, also known as the ringed worms or segmented worms, are a large phylum, with over 17,000 extant species including ragworms, earthworms, and leeches. The species exist in and have adapted to various ecologies through natural selection, some in marine environments, as distinct as tidal zones and hydrothermal vents, others in freshwater, and yet others in moist terrestrial environments. The annelids are bilaterally symmetrical, triploblastic, coelomate, invertebrate organisms. They also have parapodia for locomotion. Most textbooks still use the traditional division into polychaetes, oligochaetes and leech-like species. Cladistic research since 1997 has radically changed this scheme, viewing leeches as a subgroup of oligochaetes and oligochaetes as a subgroup of polychaetes. In addition, the Poganophora, Echoura and Sipuncula, previously regarded as separate phyla, are now regarded as subgroups of polychaetes. Annelids are considered members of the Lophotrochozoa, a superphylum of protostomes that also includes mollusks, brachiopods, flatworms and nematodes. The basic annelid form consists of multiple segments. Each segment has the same sets of organs and, in most polychaetes, has a pair of parapodia that many species use for locomotion. Septa separate the segments of many species, but are poorly defined or absent in others. And Echoura and Sipuncula show no obvious signs of segmentation. In species with well-developed septa, the blood circulates entirely within blood vessels, and the vessels in segments near the front ends of these species are often built up with muscles that act as hearts. The septa of such species also enable them to change the shapes of individual segments, which facilitates movement by peristalsis or by undulations that improve the effectiveness of the parapodia. In species with incomplete septa or none, the blood circulates through the main body cavity without any kind of pump, and there is a wide range of locomotory techniques. Some burrowing species turn the pharynges inside out to drag themselves through the sediment, although many species can reproduce asexually and use similar mechanisms to regenerate after severe injuries. Sexual reproduction is the normal method in species whose reproduction has been studied. The minority of living polychaetes whose reproduction and life cycles are known produce trochophore larvae that live as plankton and then sink and metamorphose into miniature adults. Oligochaetes are full hermaphrodites and produce a ring-like cocoon around their bodies, in which the eggs and hatchlings are nourished until they are ready to emerge. Earthworms are oligochaetes that support terrestrial food chains both as prey and in some regions are important in aeration and enriching of soil. The burrowing of marine polychaetes, which may constitute up to a third of all species in nearshore environments, encourages the development of ecosystems by enabling water and oxygen to penetrate the sea floor. In addition to improving soil fertility, annelids serve humans as food and as bait. Scientists observe annelids to monitor the quality of marine and fresh water, although bloodletting is no longer in favor with doctors. Some leech species are regarded as endangered species because they have been over-harvested for this purpose in the last few centuries. Ragworms' jaws are now being studied by engineers as they offer an exceptional combination of lightness and strength. Since annelids are soft-bodied, their fossils are rare, mostly jaws and the mineralized tubes that some of the species secreted, although some late Ediacaran fossils may represent annelids. The oldest known fossil that is identified with confidence comes from about 518 million years ago in the early Cambrian period. Fossils of most modern mobile polychaete groups appeared by the end of the Carboniferous, about 299 million years ago. Paleontologists disagree about whether some body fossils from the mid-Ordovician, about 472 to 461 million years ago, are the remains of oligochaetes, and the earliest indisputable fossils of the group appear in the Tertiary period, which began 65 million years ago. Classification and diversity. There are over 22,000 living annelid species, ranging in size from microscopic to the Australian giant Gippsland earthworm and Amanthas mekongionis, which can both grow up to 3 meters long. Although research since 1997 has radically changed scientists' views about the evolutionary family tree of the annelids, most textbooks use the traditional classification into the following subgroups. Polychaetes. As their name suggests, they have multiple chaetype segment. Polychaetes have parapodia that function as limbs, and nuchal organs that are thought to be chemosenses. Most are marine animals, although a few species live in fresh water and even fewer on land. Clytolates. These have few or no chaetype segment, and no nuchal organs or parapodia. However, they have a unique reproductive organ, the ring-shaped clytellum around their bodies, which produces a cocoon that stores and nourishes fertilized eggs until they hatch, or, in monilogastrid, eukaryotic eggs that provide nutrition for the embryos. The clytolates are subdivided into oligochaetes, which includes earthworms. Oligochaetes have a sticky pad in the roof of the mouth. Most are burrowers that feed on wholly or partly decomposed organic materials. Hebridinia, whose name means leech-shaped, and whose best-known members are leeches. Marine species are mostly blood-sucking parasites, mainly on fish, while most freshwater species are predators. They have suckers at both ends of their bodies, and use these to move rather like inchworms. The Annelida, minute annelids that live in the spaces between grains of marine sediment, were treated as a separate class because of their simple body structure, but are now regarded as polychaetes. Some other groups of animals have been classified in various ways, but are now widely regarded as annelids. Pogonophora, Ciboglinidae were first discovered in 1914, and their lack of a recognizable gut made it difficult to classify them. They have been classified as a separate phylum, Pogonophora, or as two phyla, Pogonophora and Vestimentiphora. More recently they have been reclassified as a family, Ciboglinidae, within the polychaetes. The Echidna have a checkered taxonomic history. In the 19th century they were assigned to the phylum Geoffroea, which is now empty as its members have been assigned to other phyla. The Echidna were next regarded as annelids until the 1940s, when they were classified as a phylum in their own right, but a molecular phylogenetics analysis in 1997 concluded that echidnas are annelids. Myzostomida live on crinoids and other echinoderms, mainly as parasites. In the past they have been regarded as close relatives of the trematode flatworms or of the tardigrades, but in 1998 it was suggested that they are a subgroup of polychaetes. However, another analysis in 2002 suggested that myzostomids are more closely related to flatworms or to rotifers and acanthocephalus. Distinguishing features. No single feature distinguishes annelids from other invertebrate phyla, but they have a distinctive combination of features. Their bodies are long, with segments that are divided externally by shallow ring-like constrictions called annuli and internally by septa at the same points, although in some species the septa are incomplete and in a few cases missing. Most of the segments contain the same sets of organs, although sharing a common gut. Circulatory system and nervous system makes them interdependent. Their bodies are covered by a cuticle that does not contain cells but is secreted by cells in the skin underneath, is made of tough but flexible collagen and does not molt. On the other hand, arthropods' cuticles are made of the more rigid alpha-chitin, and molt until the arthropods reach their full size. Most annelids have closed circulatory systems, where the blood makes its entire circuit via blood vessels.